Now let's start using the tool on a few examples to see how it works. So we'll leave it at this time, just in imperial units. I've pre-populated the data, 2100 RPM is the prime mover. A number 1 for the input gear ratio and a number 1 for the output gear ratio means that there's no input or output gearbox. 5,000 PSI is the maximum operating pressure. And then we wanted an 800 foot-pound torque requirement. And then we wanted 750 RPM out of that motor. So you can see it's already provided us a P6 pump with an M14 Gold Cup motor. The pump's operating at 93% of its full capacity, full displacement. It's operating at 2100 RPM, same as the prime mover. And then the pressure is 45-35 PSI. So it's not all the way to max system pressure capability. So in this case, we want to take, and 93% stroke is good. If we have the ability to run at a different prime mover speed, we could actually drop that prime mover down to 2000 RPM if we wanted. That was more efficient, or it was better for the prime mover. And also then you can run your pump at a higher displacement, up to 98% of full stroke. The higher the stroke angle, the more efficient the pump is. When you get down at low stroke angles, the hydraulic pumps become a little less efficient. So these are things you can play with in order to try to maximize your efficiency and see where you're going to be running at.